In this screen we have several different types of commands that are going to be more towards mathematics, simple math. What I have right here in line 0 is an input that activates what's called a move command. Now that move command has got a source and a destination. It's going to take whatever value is in N70 and move that value to output 0. 0.0 is going to be basically the entire output cards. Output 00. Now the next line, when this button is pushed, it's going to take this output right here, the entire output card 16-bit value, which is currently 0. It's going to add the number 1 to it. Okay, and it's going to take the sum of whatever this is and enter it in N71. Well, first of all, what the heck is an N7? All programming has what are called integer files. These are places to store numbers. Some programs will actually let you see the files, others will not. I can look at this file in binary numbering. I can look at the file in octal numbering. I can look at these files in decimal. I can look at them in hexadecimal. I can look at them as ASCII or ASCII code. My preference is decimal. So right here I have the number 255 stored right there in N70. So this number 255 shows up right here. N70 currently has the number 255. The output file is currently 0. So I open up my output files. There's my output 00. We'll change the view to decimal. This file is currently the number 0. This would be the value of whatever outputs are currently turned on. So binary again, every one of these are screw terminals. Every one of these screw terminals will be on or off. I can look at them as individual terminals or a 16-bit word. And that 16-bit word can be converted to any one of the numbering systems we need. Very easy to work with. Now right here we have N71, which is currently the number 0. So we're taking one value, adding the number 1. We're taking the value in N71, currently the number 0, and we're going to subtract the number 129. Once that number is subtracted, we store that number in N72. Now we're going to take that number in N72 and multiply it by 2 and store it in N73. We take that number in N73, we divide it by 3 and store it in N74. Well, notice there's no commands in front of these commands. There could be, but there doesn't have to. The example here is just showing how the commands work. So programming, you can see a lot of these types of commands. It all depends on who had the job of programming. So if I go ahead and download, I'm going to download this. We do not apply communication change. We go back to run mode. We go online. Well, right here I'm going to bring up my N file, integer file. There's all these numbers right here. N70 currently stores the number 255. But now my outputs, output 0 is 0. So let's look at the output file. We look at the output file in decimal. When I go ahead and push that button right there, input 1, that took the number 255 and moved it to the output file. Well, what that means to you is if I look at this at binary, I just turned on every one of these terminals at one time. And I did that by turning on, just pushing a button. So I can take a value and move it to any location I want. This could be analog, this could be digital, it could be virtually any location. I can move this into the preset of a timer, counter, do anything you want by changing the destinations. But now look at this one. Source A is now 255. Okay, we added the number 1 and store it right there in N71, which is currently 0. That's because I have to hit the button to do this. Let's bring up the integer file. I push the input 0, 1, 2, and now we got 256. Well, 256. Now we subtract that number. 256 minus 129, the resultant is 127. Now we're taking that 127 and we're going to multiply it by the number 2. 127 times 2 is 254. There's our 254. Now we take that number and divide it by 3 and we get the number 85. Well, wait a minute, that doesn't look quite right. If we take that number 254 and divide it by 3, we're going to have a remainder. Well, the problem here is these numbers we look at are actually binary numbers. How do you create a decimal point in binary? You can't. So when we're using a binary to decimal conversion or binary conversion to any numbering system, what will happen with the math is if there is a remainder, it will round the number up or down. Less than 5 will round down. 5 and greater will round up. So the numbers will round themselves out. There's your divides. So we can use all the different types of math commands. And based on the processors, there are different types of maths, from square roots to trigonometries. But getting down to the basics, most all the programming you see are going to be in some form of relay ladder logic.